Speaker today is Carol Stoker. She's NASA Ames Research Center. I'm going to talk to you about her recent research. Please welcome Carol Stoker.
Good morning. Looks like I'm going to be doing a couple of talks today. So the first one, I'm going to talk to you about a project that I'm doing at the Mars Desert Research Station called Drilling on the Moon and Mars in Human Exploration, or DOMEX. This project is in collaboration with Bernard Foyng, who's the chief scientist of the European Space Agency's technology office in Noordwijk in the Netherlands, engineer at NASA Ames, Johnny Zavaleta, and John Clark, who's with Mars Society, or I guess he's the president of Mars Society Australia. Okay, so first I'm going to talk to you about the Mars Desert Research Station and lessons learned from 10 years of operation of that station. And then I will summarize the project that I'm specifically involved in that's been working there for the last year, or a little over a year now. So first of all, lessons from a decade of operating the Mars Desert Research Station. This is a picture of the station here in the surroundings. And I think when the site was selected, it was selected probably more for scenic beauty than for its value as a Mars analog. However, as it's turned out, its value of as a Mars analog is actually extraordinary. There's just a huge amount of information we've learned about Mars in the decades since this habitat was constructed that has taught us what a great analog it is, things that we really didn't know about 10 years ago. So here's a diagram showing where it is, the state of Utah. It's actually in south central Utah right here. And it's at the south end of it, an area called the San Rafael Swell. This is a wilderness study area, and it's Bureau of Land Management land, and it's at the south end of Canyonlands National Park, and it's geologically similar to the structures in the Canyonlands National Park. So Mars Desert Research Station was built and operated by Mars Society. The location is near the town of Hanksville, Utah, which is a town of about 300 people. And the idea is that it's a simulated Mars base station operated since 2001. And it has no paid staff, completely organized and operated by volunteers. There is one person in Utah who gets a very small paycheck to basically to go fix other people's, fix problems that are usually caused by other people. There have to date been 94, or Bob Zubrin tells me it's 95 crews that have rotated through the station since 2001. So 500 people have been out there, which is actually an extraordinary number, and it's turning out to be a major source of training of the next generation of space explorers. Pretty much everyone who's applying to be an astronaut today has a stint at Mars Desert Research Station as one of the things they put on their resume. I made this point to NASA JSC recently. It's generally viewed by all the participants as a very valuable experience. And many of those participants are students. And now, having been 10 years of it, there are many former students that were out there when they were students. And when you go out there, you actually see their names all over the place because every crew has a badge. I'll show you some examples of that. So what happens at MDRS is engineering research. A lot of these crews, probably too many in my opinion, tend to be engineers. So their surface exploration systems are one of the things that people tend to work on, and the Hab itself ends up offering a lot of projects. Environmental systems, communications, robotics. My project in particular is more robotics focused. There's an aspect of scientific research. The geology of the area is outstanding. As I said, it's an outstanding Mars analog from a geological perspective. Astrobiologically, there's a lot of interest as well. And there are opportunities for human factors research, including psychological and social aspects, crew dynamics. And finally, education and outreach has been kind of a cornerstone of the project. There have been many student activities, teacher training type activities, and media events of various kinds. Very often crews out there have some kind of a press conference, or the media comes out for some reason. As I understand, this summer there was actually a movie crew out there filming in that area. The geology, and to say something about why is it an interesting Mars analog. So this is, if it were in a stack, it would go like this. So this is youngest to oldest. This is actually the actual outcrop of Factory Butte. It is a huge bed of shale. It's like 3,000 feet thick. It's called the Mancos Shale. It was deposited in the late Cretaceous era. The Cretaceous was, the end of the Cretaceous era was when the dinosaurs were killed. So this is about, all of these things are representative of the time of the dinosaurs. And during the period of the end of the dinosaur era, this was a deep sea bed. And it is a shale, and it's very organic rich. Directly underneath that is a sandstone deposit from the late Jurassic era. It's called the Dakota Sandstone. Directly under that is the Morrison Formation. This is where the Hab itself is located in the Morrison Formation. And these are clay hills, primarily. But it was a late Jurassic era floodplain deposit. An important thing to note about the Morrison Formation is that it is also the site of Dinosaur National Park, which is in another part of Utah, and some of the richest dinosaur bone and dinosaur deposits in the world have been found in the Morrison Formation. And recently there's been a big find discovered quite close to where the Mars habitat is. And then finally underneath that, again going older in time, is this this unit called the Somerville Formation, and it's a finely layered sulfate-rich deposit that was laid down in tidal flats in the middle Jurassic era. This is actually a very interesting Mars analog, as is this, because of this finely layered sulfate-rich sediments. And actually these are also very sulfate-rich. Sulfates are actually very dominant on Mars. There are areas of Mars where there are huge, finely layered sedimentary beds that appear to be very rich in sulfates. So again, this is one of the chemical or geochemical reasons that this is a very good Mars analog. Here's a layout of the habitat, or actually you might think of it as the Mars base area. Hab in, and actually there's a cliff right here, and just above the Hab there's a small optical observatory that was donated with funding by Elon Musk, who probably some of you have heard of. He's now has his own space launch business and also his own electric car business. The idea here is that these outlying areas are connected by what would be pressurized tunnels. In reality, they aren't, but they're accessible without going on EVA. Let's put it that way. So, in keeping with the simulation, you can get to these outlying areas by following these paths. And the idea would be that you would actually be in a pressurized environment. So there's an area that's basically parking for all-terrain vehicles, and over sort of behind a hill, and there's a little hill right here, is an engineering area. Okay, so this is the Greenhab. Just to show you pictures of some of this stuff, there's a set of radio telescopes next to the Greenhab. Here's the engineering area where actually there are diesel generators that provide power source. You wouldn't use diesel generators on Mars. You'd probably use a nuclear reactor, but same idea. There would be a source of power relatively near but not in the habitat. Here's the hab itself and the Greenhab. The Greenhab actually has wastewater treatment. So wastewater gets pumped out of the habitat into the Greenhab, into tanks in the Greenhab, and then in those tanks there are biological systems to clean the water, which is then recycled back into the habitat. And then finally up here on the knob behind the habitat, the optical observatory. Okay, here's the inside of the hab. So it's basically an 8-meter diameter by 8-meter tall structure with 2 decks. The lower deck has workshops and EVA area, spacesuit area, and laboratory area, and also say EVA airlock, an engineering airlock, a shower, a toilet, and the upper deck has crew cabins, adequate for having 6 people in crew cabins, a mess area, and a computer workstation area. So to show you the views of the different things. This is a view into a crew cabin. They're really small, but actually remarkably cozy. It's surprising how comfortable you can get in something as small as those crew cabins. There's a ladder access to a loft area where there's storage. There's a galley, a area for doing computer work, and an eating and meeting area. Experience is that the upper deck is actually very comfortable. People like to hang out there. Here's the lower deck area. Lab benches, a small area for suiting up for EVA, a workshop area which is kind of multi-use depending on what exactly is your function and interest. And experiences that the lower deck tends to be crowded, cold. At least most of the hab operations are done during the Utah winter, and the thermal control of the habitat isn't very good. Lessons for future activities and for Mars exploration itself is that both the work area and sort of the living area need to be equally comfortable so that the crews are taking better advantage of all the habitable zone or habitable area. Experiences most of the crews rarely venture down in the lower deck, and I think that that's primarily because it's just not as comfortable. Okay, leadership and decision making is very important at MDRS, how you do it. The crews often are selected as individuals and not as crews. They typically show up in Utah. They haven't trained. They often are meeting each other for the first time. So the process for decision making is a really important thing. The extravehicular activities, going out and doing work, really requires teamwork. We have found in our activities, and I'm actually reflecting John Clark's views on this, that having a duty officer, somebody who's appointed to basically be, as John calls it, the habnag for the day. That's somebody who suits the crews up, keeps track of where the